Hey, what's up, guys? Welcome back. I hope everybody had a great spring break. This is week 5, 6, I don't know, I can't even remember. The coronavirus shutdown. Please continue to do your online schooling from your academic classes. I know several of you are having problems doing that, but please continue to do it. Work hard at it. If you got any issues, let me know, and I'll do the best I can to help you out. There's also your counselors, your teachers themselves. I'm sure you have their emails as well, and the deans if need be. But there's always we'll work hard to find a solution to any problems that you're having that are keeping you from getting that schoolwork done. Please stay at that and get that finished. So last week the week before last we talked about weld symbols, basic weld symbols. We talked about welding positions, things of that nature. Today we're going to talk about where'd it go? Identifying shapes and dimensions of metals. Now I apologize because we did a lesson like this a little bit ago, probably about 6 to 8 weeks ago. I even did it for my observation, and I thought the lesson was a little confusing myself. And then I found this, which is like a precursor to everything that we did a few weeks ago. So I apologize, that's my mistake. We should have done this lesson first, and then the lesson over structural shapes after this. This is kind of really a basic introduction to what we were getting into 8 weeks ago. So I'm sorry for the flip-flop. You guys did a great job in adjusting to the content that we did 8 weeks ago, and I think we got through it, but had I done it this way, we'd have been probably a little bit better off. So here we go. Today we're going to work on identifying structural metal shapes. So, an introduction. As preschoolers, we learned about basic shapes like circles, squares, triangles, and rectangles. And we figured out how they fit into puzzles. The diesel students are still trying to figure this out, so you guys are ahead of them. As welders, we must learn new shapes and figure out what type of welding they're used for and where they fit inside of a weld. The following material will introduce you to the most common shapes of structural steel, how these shapes are made, and how they are measured. Learning all there is to know about these shapes is an important part of the welding learning process, just as learning basic shapes was an important part of our education as children. I was just kidding all you diesel students that may or may not see this. Just joking. Can't wait to see you again. So let's go over some of these basic shapes. Rebar. Now let me point this out. R-E-B-A-R. There is no B on the end of that. Drives me nuts when I hear young people say rebarb. It's not rebarb, it's rebar. Okay? Channel. You can see a lot of times we call that a C channel. If you were to flip it on the side, it would look like a C. Square or rectangular, sheet plate. That's your basic bar stock flat stock that you use for your weld coupons. Standard I-beam. You can notice it looks like an I. Square or rectangular tubing. Round stock. Angle iron, pipe round tubing. Flat bar, and wide flange beam. Identifying the structural steel shapes. The versatility of steel and its strength to weight ratio is the ability to be infinitely recycled. The versatility of the steel, its strength to weight ratio, and its ability to be infinitely recycled into new products, which means you can basically take a building that's 100 years old, tear it down, take all the structural steel inside of it, melt it back down, and repurpose that for new material. It's infinitely recycled into new products, sets the steel apart from many other materials, making it one of the most popular materials on Earth. This reading briefly explains the common shapes and methods of measurement for structural steel. The 8 most common shares of structural steel are shown in Figure 1 and 2. There are 8 most common structural steel shapes of steel. Don't forget that. Bar stock. I think you guys all know what bar stock is. It is a solid metal structure piece or structural piece. Bar stock is manufactured in a variety of end shapes, meaning if I were to take that bar stock, turn it down, and look toward the end of it, down the piece itself, that bar stock can be an octagon shape. It can be a flat shape. It can be square, round, hexagon, octagon. As I said, bar stock is specified by the type of metal, the diameter, thickness, width, and length. So the type of metal is an aluminum, steel, a hardened steel or a tool steel. And what is the diameter, the thickness, the width, and the length? Those are all how bar stock is measured. Angle stock or angle iron is a common structural metal shape used in construction. Angle stock is specified by the type of metal, the thickness, the width of the angle, and the length of the stock. Some angle stock may have angle sides of different widths. For example, one angle side could be 2 inches and the other 3 inches. So they can have uneven legs, basically. So one side of that angle can be 3 inches tall, the other side 2 inches. Angle stock is typically a 90-degree angle. Figure 2 shows the parts and pieces of angle stock. So here's figure 2. You see the leg thickness, you see the leg length on each side. So you have the thickness of the material, the leg or the leg length, and then the length of the stock itself. Rebar is short for reinforcing bar or reinforcement bar. Rebar is a deformed round bar stock with a high carbon content used for reinforcing concrete. The size of rebar is expressed in the U.S. as imperial bar sizes, which give the diameter of units of 1/8, so that a number 8 equals 8/8 of an inch, or 1 inch in diameter. The cross-sectional area of number 8 bar is 0.790 square inches. And again, just to refresh, rebar, I'm sure you guys have seen it around all the time. Even laying around in lab in the back. When we had the masonry program up right beside us, they used rebar all the time for reinforcing their walls. They would basically stick pieces of rebar down in the block and then pour the block full of mortar, and that creates a more solid structural bond. They also would lay this rebar in grid patterns in the ground wherever they were going to pour concrete, and put that up off the ground just a little bit, pour the concrete on top, and then it creates a rigid bond of like a structural steel with concrete cladded structural steel to give it more rigidity and keep it from cracking. So we've covered, again, just to recap, we've covered bar stock and angle stock and rebar. Now we got metal sheets. These are the most common that you see in the lab. We get these a lot in the 4x8 sheets. We get them in 6-inch strips of, 6-inch, 20-foot long strips that we cut into coupons as well. So these metal sheets and plates are flat pieces of metal. Sheets are generally considered to be thinner than plates. Sheets and plates are commonly 4 feet wide and 8 feet long. The thickness can be expressed in inches, millimeters, gauge, mils, or other units. Sheet can be solid or perforated with holes. Expanded sheet steel is a common example of perforated metal with diamond-shaped holes. Expanded sheet steel, a real good example of that would be the trailer that we had in lab. The rear ramp or the rear tailgate is all expanded metal. So that's sheet metal as well, sheet steel. Channels are U or C-shaped metal structure pieces. They look like 2 pieces of iron or angle iron welded together to form a channel. Channel stock is sized as if it were a rectangle, indicating the height, the width, the thickness, and length. So that's very important to remember. Just think of it as you're looking at a rectangle. C channels or U channels are measured, indicating the height, the width, thickness, and length. Figure 3 shows the parts of a channel. Right here. So you have the flange length, you have the depth of the web, and you have the web thickness. So the web thickness is that piece in between the 2 flanges. How thick is that piece in there? That's the web thickness. Okay? and this will be an I-beam, and it's going to show the flange here, the flange width, the depth of the web, and the web thickness. Okay, when we refer to web, let me go over this one time. When we refer to web, we're talking about the middle material that joins the two flanges. So right back up to a C channel. Again, you have the web here in between the two flanges. So anytime we talk about web, that's the part of the material that we're talking about. And here we have a wide flange beam. Again, you have the same thing, depth of the section, so that's the depth. You have the web thickness here, and the flange width. You also have flange thickness on an I-beam, or I'm sorry, on a wide flange beam. So I-beams are common structural metal that are used in construction, so called because they have the shape of an I, obviously. There are several variations based upon the relationships of the height to the widths, as well as the thickness of the materials. Figure 4 shows the parts of an I-beam. We already went over that. Wide flange beams, figure 5, we went over that as well, shows the parts of a wide flange beam, also known as an H-beam. Tubing and pipes. They're hollow materials. Pipes are almost always round shapes. Tubes can have a variety of shapes, being square tubing or round tubing, and rectangles and ovals as well. Generally, pipe is sized relative to its inside diameter, with a wall thickness expressed as a schedule. So, as opposed to like the web or the flange thickness of structural angle iron or C channel or whatever, or I-beams, the thickness of the material in pipe is described as a schedule. Schedule 40 and 80 pipe sizes are common. It is noted that while Schedule 40 and Schedule 80 steel pipes have different wall thicknesses, their outside diameters are the same. So they can be used with the same size threaded fittings. So again, those are all standard outside diameters of the pipe itself. The difference is the wall thickness or the thickness of the material itself. Schedule 40 is a thinner thickness, or is a less thick schedule than Schedule 80. Schedule 80 is a higher thickness wall measurement. The inside diameters vary slightly. Obviously, the inside diameters, if the outside diameter stays consistent and the wall thicknesses vary slightly, that obviously means that the inside diameter is going to have to vary as well. Not a lot though, because there's not a whole lot of difference between 40 and 80 schedule pipe, to be honest with you. So they can, let's see, the inside diameters vary slightly. Tubing is generally sized by the outside measurements and wall thicknesses of the materials. Wall thickness can be expressed in US or SI decimals, standard international, fraction, or gauge. Table 1 and 2 for more information. We're going to leave it right there at that. In our next go around, we'll go over all these dimensions and I guess dimensioning itself for the materials. So the gauges, mils, decimals, things of that nature. Wall thickness and schedules. We'll talk about how to measure these pieces of structural steel. So just to recap, we went over the 8 basic structural steel shapes, and those are again rebar, not rebarb, channel, sheet or plate, standard I-beam, square or rectangular tubing, round stock, angle, pipe or round tubing, flat bar, and wide flange beam. I hope everybody's staying safe. Please let me know if you need any help. I'll be sending out a quiz directly following this video upload, which, by the way, I'm sorry it's late. This thing takes me about 6 hours to upload. My Wi-Fi is terrible. So as soon as I get it uploaded, I'll send it out to you guys. I'll have a quiz followed up right behind it. If you can do that and get that taken care of as quick as possible, that'd be great. I'm going to have this in the directions for the quiz as well. But here's my challenge to you. You have 8 structural steel shapes. What I would like for you to do by the end of the week, and I'll give you 2 extra credit points per shape that you send to me. I would love for you guys to go around and take pictures of structural steel shapes that you find around your house or wherever you're at, Hopefully it's around your house. Look under the car. Check out the frame of the car. Try to find metal structures in your backyard or pieces of metal laying around, and try to identify those round stocks, that rebar, those channels, those angle irons, anything you can find. Take a picture of those and send them to me, please. And make sure that with that picture, you're identifying them correctly with the name of that structural steel shape. Okay, so that's my challenge to you. It's going to be out in the new in the email with the quiz to follow as kind of a reminder. But please take a look at this stuff. It's the least we can do. We're not in the lab every day, so let's just try to put our hands and our eyes on something that we can relate to here on this screen. So I hope you guys are having a great week. I hope this message finds you well and safe. Again, thanks for tuning in, and I'll see you here in a couple days.